Hey everyone, we're going to take a look at exercise 21, which is after theory B, so we're going to take a look at the volume of a cone. But if you take a look at question 21, hopefully you see that this is not in its entirety a cone, right? Only this part here is a cone. So if you want to calculate the volume of this pencil, which is the question of A, you also have to calculate this part here. And I have maybe already spoiled it a bit, but that is a cylinder. And the volume of a cylinder, that was in the prior knowledge, right, was pi times r squared, the radius squared, times its height. So the calculation that I'm going to do is I'm going to calculate the volume of the cylinder. And I'm going to calculate the volume of my cone. The volume of the cylinder is pi times r squared. What is r? Not 1.5, right? R is a half times 1.5, because 1.5 here is the diameter. So it's 0.75 centimeters. So pi times 0.75 squared times the total length, which is 10. And if I'm going to calculate that, let's take a look. Pi times 0.75 squared times 10 gives me around approximately 17.671 cubic centimeters. The volume of a cone, that's the new formula, right? That was 1/3 times pi times radius squared. Radius is the same radius is right here, right? And the height in this case is a bit shorter, it's 2. And we're going to calculate this too using a calculator. So we're going to do 1/3 times pi times 0.75 squared times 2. That's a whole lot less, I can tell you. It's going to be 1.178 squared centimeter. So the volume of the pencil will be 17.671 plus 1.178, and again now I have to round. This will be 17.671, around 18.85, because they want 2 decimal places, cubic centimeters, because we're talking about centimeters. Okay, so you have to calculate those two volumes separately, and then in the end you're going to add them up. For the volume of a cone, don't forget to add the 1/3, right? 1/3 times pi times the radius times 2. Okay, at B. Should I do it right here? I can do it right here. I think that's nicer. The pencil is made of wood with a density of 0.9 grams per cubic centimeters. The volume of the lead is 2.3 cubic centimeter and its density is 1.2 grams per cubic centimeter. What is the weight in grams of the pencil? Round to 1 decimal place. Let's take a look. How can we calculate this one? Oh, luckily they give us what the volume of the lead is. I was misthinking about this, because otherwise it's going to be difficult. So there is a total volume of 2.3 cubic centimeters of lead in there. So that means of my total volume, this is my total volume, wood plus lead, minus the lead, that will leave me with I don't need a calculator for this, by the way. 16.55 cubic centimeters. So this is what I'm left with, and now we have to carefully note that there is 16.55 cubic centimeters of wood, and there is 2.3 cubic centimeters of lead. How much does they weigh? Well, the wood weighs 0.9 grams per cubic centimeter, and the lead is a bit more dense. It's 1.2 grams per cubic centimeter. So the wood weighs 16.55 times 0.9, because 1 cubic centimeter is 0.9, so 16.55 is 16.55 times that, which is going to be 14.895. In this case, grams, right? We're now talking about grams, not about volume anymore. And the other one is 2.3 times 1.2. 1 gram of lead is 1 cubic centimeter of lead is 1.2 gram, but I have 2.3 of them. So I have to do 2.3 times 1.2, which gives me 2.76 gram. So the total weight of this pencil, so weight pencil, is going to be 14.895 plus 2.76. And they say now round to 1 decimal place. They are a bit picky during this exercise. First 2, now 1. So the answer is going to be 17 points, approximately again, because I round, 17.7. Not grams, for cubic centimeters, grams, right? We're talking about grams. So 17.7 gram, and that's your final answer. Again, just as with the exercise about the pyramid, which was 16, I think, yeah, that one. Exercise C, this is a bit more physics, right? We're now combining our knowledge of volumes and mathematics together with practical exercises with more physical based or physics based theories about density, for example, which I think is very nice because that gives you practical examples of when you can use mathematics in real life situations. Practice the rest as well, and if you have any questions, then feel free to ask during the lesson. Bye!